welcome to my channel. This is Further Solutions Academy. Further Solutions Academy. Encourage us more. Help us to share our video. Share our video to your friends. If you have not subscribed before, and also make sure you subscribe to it. Please help us to subscribe to this channel. And as we are telling people about this channel, help us to tell them to subscribe also. Please do that for us. This channel, any mathematics problem you find so difficult, just come down to this channel. It will surely be solved. Any of them that has parts, make sure you start from part 1. And before we move on to advanced mathematics, the advanced one among them are very much the one of first order, second order, Fourier series, Laplace, and so on and so forth. Before you watch those videos, make sure you are okay with your differentiation and integration. There are integration videos there, there are differentiation videos there also. And thank you so much. I really appreciate you for your compliance. The level of your is very, very good. Thank you so much. And in this video, I want to be walking you through the reduction order of, the reduction of order method part 1. That's what I'm walking you through. And the outline, I want to work on the definition of this particular method. It's a method of ODE. And second, the cases of what? Of reduction order of method. Now, okay, let me start from the first outline, which is called definition. Now, if I'm talking about definition of ODE, before we move on deep, I have to let you know the meaning of ODE. If I have a particular function this way, a of y prime of x plus what? b of y, this one can be prime of 1 prime of x plus I can have let me have cy of what? Of x equals to q of x. When I was explaining q of x, when I was explaining the first order of ODE and second order, I let you know that this is the second order. The order of this differential equation is 2. Now, and we have to understand that this one, there are also two cases. I told you that we have homogeneous when it comes to second order, and we have non-homogeneous. Now, when my q of x is equals to 0, this is known as what? Non-homogeneous. That is known as non-homogeneous. Please take note of that. It's very, very important. Non-homogeneous. Now, and also, if it's not equals to 0, and if my q of x is equals to 0, this one is called homogeneous. I've explained that one very well. Please take note of that. This is called homogeneous, and this one is called non-homogeneous. And I've given you the several case on our second order. Please make sure you view that video to be able to get it right. Because if you are not very good in second order, you may not understand what you are going to be doing in this method. Because that is why our platform here is series, one after the other. I make it so simple and nice. But you must not jump, except you are okay on those areas. Now, let me quickly go back to my reduction method. Now, if I have this type of problem, now this is a very good problem of ODE. Now, the cases is number 1. Just note this particular option. An ODE, order differential equation of order n can be reduced by 1 to order n minus 1. If that is the condition, if the equation happened to be 1 following. Okay, today, one of the following. Now, happen to one of the following. The first one is number one. Please take note of these cases. The ordinary differential, ODE differential equation does not contain the independent, please, independent and variable. Hope I'm not making a mistake. Independent variable of y. Okay, explicitly. Now, IE, that is to say, my y prime prime equals to y prime. Okay, y prime prime equals to that is what I'm going to say. Y is absent. Y is what? Is absent. Is absent or missing, or y is missing. That is number one. Number two, the ODE, differential equation, the differential equation does not contain the independent variable independent variable explicitly. That is to say, y prime prime is equals to, let me put f here, option, so that using the f of brackets of y prime. This one is if x is what? If x is missing. Okay, the third one is The third one is if the ordinary differential equation is homogeneous. Is homogeneous. I think that is the third one. Now, these are the things that we need to understand as far this method is concerned. Now, these are the things we need to understand. I will now move on to the cases now. This one will give us case 1, case 2, case 3. The first one is what? When my y is absent. That is my first case. My second case is what? When my s is what? Is missing, which is absent. And the third one is when is what? Homogeneous. That is the 3 cases that can ever happen here. Now, I will now deal with these cases one by one. That should now be the next. Okay, let me just move on to the first case. Now, the first case, let me just try to understand the first one, which is called case 1, which is dependent variable absent. Dependent variable absent. Now, if my dependent variable absent, it means it's telling us that what? Y prime prime is equals to what? F prime of y of x, something like this. Now, what I will do, if I have this type of problem, what I will just do is that let my y prime equals to what? F of what? Xv. That is what I will do. Now, if I want to work on it, it means that we then say solve Okay, then what do we mean is for v? We get solve for v, and next get or obtain. Let's get. Let me use the word obtain. Obtain your y. That is just already. Now, with the help of what? Integration. With the help of what? By what? By using integrating factor method. Giving factor method. Let me just use that. Okay, that is what we want to be working on at this as far as this case is concerned. Now, I will try to give an example that will please take note of that. What am I trying to say? Okay, you will see it clearly now. Now, as far as what this is concerned, let me quickly use an example to back it up. Now, you have to understand our integrating factor method very well at this point. Now, for instance, if I have solved this particular problem, solve x y prime plus y prime equals to 4x. I want to solve this particular problem. How will I solve this problem? I want to use the reduction formula. Solution to this problem. What I will just do is that what? Let my v equals to what? Y prime. And my v prime also implies v prime equals to what? Y prime prime. Now, since I have this for this and also this for this, okay, what I will just do is that I will come back to my equation and put those v. What I will have s v prime plus v equals to 4x. That is what I want to have. Since I have that, I can now solve my problem without no issue. Now, since I substitute this for this equation, this is equals to this, and this equals to this, which I've done that for this, and I've done that for this. Now, since I will now have that, I will now work towards my integrating factor method. How will I achieve my integrating factor method? Divide all by what? By x by x. This will give us this s prime plus what? V of what? Of x equals to what? 4 equals to 4. Since I have this, I will now go by my what? Integrating factor. How do I achieve my integrating factor? You have to understand what is called p of x, which is equals to what? 1 all over x, and my q of what? Of x, which is equals to what? My 4. Now, how will I go by integrating factor method? My p of s, my integrating factor is telling us that what? Exponential function of integral of what? P of x dx. Now, which is my p of s dx, which implies integrating, exponential function of what? Integral of 1 all over what? Of x dx. Now, if I integrate this, I will have my exponential this is equals to what? Equals to x, which is going to be giving me, okay, for those that are still learning, for upcoming people, I can turn it to what? Ln of x. Ln of x with the help of your logarithm function, logarithm laws, you will have your what? X. Now, after having my x, I want to apply my what? Integrating factor. What I will just do is that I will multiply integrating factor equals to what? Integral of what? Q of what? Of x with what? Integrating factor also with the x. Now, by so doing this, I'm using my what? Integrating factor formula. Now, what is my integrating factor? We have x. I will have v of x equals to integral run from what? What is my q? I have 4, and the integrating factor is what? Is equals to what? X dx. Now, what will I get if I integrate this rubbish? I will have what? My v of x equals to what? 4x, which I'll be having 2. Sorry for those integration, it will not be a problem. This now 2 plus what? Plus my key. Now, which is called my constant because it's known as what? Is an indefinite integral. Now, since I have this, I can now move on by having what? What do I need? I need my v. My v, divide all through by what? Divide all through by what? By x. By x. This will cancel this. My v equals to what? 2x plus what? K of inverse of x. Now, since I have this, I will now move on. Don't forget that on hence my v equals to y prime. My v equals to y prime, and my y prime can also be written as what? Dy dx. Don't forget that. Now I can now say that what? My dy dx equals to 2 of x plus what? K of x minus all brackets. If I multiply all through by what? I can now say that what? My dy equals to what? Dx. If I should integrate, I integrate. Now, for me to integrate this function, I will have a very good something to back up with, which I'll be having. Now, this one will be what? My y. Let me put my y of x. It's not it's possible to have that. Now, if I have my y of x, a function, it will be equals to, what am I going to have here? This one will be what? X squared. I'm integrating. This one will give me what? If I should integrate this particular function, I'll be having this one will be, if I added one to it, and also okay, I'll be having k ln x, because it's an inverse, which is our plus k ln x, and plus what? Let me plus c, another constant. Please, k and c are constants. That is my final answer. That should be my what? My final answer. Can you see that this method is very, very nice and very sweet? It's very nice and sweet. Okay, I can now move on. Let me give more example on this case 1. Please make sure you understand this case very well. It's very, very simple to know. Okay. But before you do find, you must understand our integrating factor very well, and also move on to that, those things very well. Now, let me try to put more examples on this reduction order method. Now, okay, if I have this type of problem, okay, that can really be of help to us. Okay, I think it's good to move on to case 2. Okay, let me try to give one more example on this this thing before we move on to the case 2. Now, I have x squared y prime plus 2xy prime minus 1 equals to 0. Now, I want to solve by reduction order method. If I want to solve this particular problem by reduction order method, it won't be very hard. What I will just do is that what? Let my v equals to what? Y prime, and also my v prime equals to y prime. Now, what I'm trying to do, I've reduced this by order with help of my definition at the beginning of the class. Now, since I have this, I can now say that what? My x squared, my v prime, which is this, plus 2x, and also what happened there, I'll be having my v equals to what? 1. I think I've taken this one to, I've added 1 to both sides. Since I have that thing, I can now say that what? Divide all, because this one, I want to work towards my what? Integrating factor. I will divide all through the what? Through the s square. Now, I'll be having v prime plus what? 2v all over x equals to what? 1 all over x squared. Now, since I have this, I can now move on to the next one. How will I get my integrating factor? My integrating factor let us to know that what? My p of x is equals to what? 2 all over x, and my q of x, it's always equals to 1 all over x squared. You can use your indicia problem, indices approach. Now, since I have this, I will now move on my integrating factor. It always equals to exponential function of p of x dx. Now, which is it to be equals to exponential function of what? 2 all over x the hex. Now, if I should do this, I'll be having my integrating factor. It will be equals to e raised to power what? 2 ln x, which to be equals to my e raised to power ln x squared, which is equal to what? X squared. Now, this is my what? Integrating factor. How will I proceed? I will now move on by having my integrating factor. It will be equals to v of what? Integrating factor. I want to multiply all through by what? Integrating factor. Now, equals to, I will now move on to the next one, integral of what? Q of x with what? Integrating factor with the x. That is how to work on what? Integrating factor. Since I have that, I can now say that what is my v? My integrating factor is x squared equals to, now my q of x, it will be what? 1 all over what? X squared. My integrating factor is what? X squared and the x. Successfully, this one will cancel this. Since I have this, I can have my v of x equals to what? Integral of 1 dx. Now, since I have that, I can answer that what? Okay, how do I go about this? I can now move on by having I'll be having v of x squared equals to what? X plus what? Plus k. Now, I divide all through by what? I have my v equals to what? 1 all over x plus what? 1 all over k squared. Now, since I have that, what is my v? My v equals to what? Y prime, which is written as what? Dy and what? The x. I can answer that what? Dy dx, dy equals to what? 1 all over x plus what? Kx inverse to inverse all brackets of the x. Now, if I should integrate, I will be having y equals to ln x. Now, if I should integrate this particular function, I'll be having minus, if I should add 1 to minus, okay, I want to add 1 to this particular function. It will be minus 1 all over 2. Yes, sorry. Okay, I want to add 1 to this. It will be minus, because I'm integrating. Okay, this will surely give me minus, normally to be minus 1 to be k raised to power x minus 1 and plus what? Plus c. Where k and c are constant, they are element of constant, please just note that they are k and what? And c. Since I have that, I can now present my answer as I want it. What's going to be, I can now say that what? My v of k is equals to what? Yes, that is my final answer. I think I don't need to go as far as anything is concerned. Now, that is the end of this first reduction method part 1. That is the end of the reduction method part 1. In next video, I'll be walking through part 2 of reduction formula. Thanks for watching.